zoom it, sir?
Okay. So start solving the question again. Is it visible?
Can you please zoom it, sir?
Zoom.
Yes.
Is it
Okay.
visible now?
Yes, sir. It's visible now.
So just calculate the zero and draw your own diagram. You can calculate here also. Draw your own diagram and you can
Mm.
start calculating here. Or
Okay, sir.
should I draw it again?
No, sir. I will draw it.
Okay. Just I want a calculation of zeros, so no need to look for the poles again.
Okay, sir.
Hmm.
Actually, I'm trying to find the intuitive way, but I'm not getting. I will go with the traditional model,
Hmm.
which contains Cl. Okay. B in 1 and B in 2. Okay. Because of this V in 1, I have Gm times of V in current here. V in 1. This current is flowing both Cx and as well as this device. So this minus gm1 is divided to cx and yeah, as well as this one. I'm assuming the current through this is I3. Okay. So I3 is nothing but called minus gm v in 1 into 1 by Sex by 1 by Scx plus 1 by gm3. The same current will mirror here. That is nothing but I4. This is
Hmm.
nothing but equal to I4. And similarly here also I have another current gm v into, and if I assume this as I out, my out current is nothing but I4 minus gm v into, and it is nothing but if I simplify this, I think I will get gm1 gm3 here v in 1 gm3 plus scx minus g, this is called gm2, this is gm2 v into. Can you scroll down, sir? Okay. Minus gm1 gm3 v in 1 minus gm2 gm3 v into minus gm2 v into sc divided by
So what is the
Is
final
it fine,
expression of?
sir?
Don't you think it is too complicated? It should come just in a few steps, 2 steps, 3 steps only.
I took the variables, so many variables that I think that's why it's became complicated. V in one,
What
V in two,
variables? Do you want to see
GM1,
whatever you've taken?
V in
Okay, now
one,
I
V in
and
two.
I got the concept that how to find a zero. Just two current paths you want to see and make this output current to zero.
Okay,
Means if there are two paths, you mean to say now this only now. If there is a some gain path and there is some different path with these two paths, overall current you want to I
equal to
out
zero.
two paths of the current. If there are two paths, this is GM cell, not AM. This is GM cell. So two current paths are there, and this current you want to make zero. So I got a concept that what is the expression for? Now you write the direct final expression of the zero and poles, then transfer function.
Okay. Pole one is at R04 parallel R02. Uh,
So
this is
this thing is a
CL.
time constant that you're writing, I think, again and again in terms of pole and all.
Uh, I think
So exactly pole means omega. It should be 1 upon that value, no?
uh, yes, sir. Sorry.
Like, yeah, yeah.
And pole two is a minus of sorry GM by the CX,
Okay.
and zero is at actually that forms a pole zero doublet. So zero is the double frequency of the second pole. This
Okay.
pole
So,
because
okay, quickly write the transfer function and
and
then, okay.
and the gain is DC gain is GM R naught.
Hmm.
Sorry, DC gain I can say minus GM R04 parallel R02. Oh, and zero
Okay, so need
one.
not to put all the things, just write in terms of x and P1, P2, P3 and all.
Okay.
Write the transfer function in terms of these variables P1, P2 and Z all. Is this the right way to write this transfer function?
Actually, one plus time constant way I need to write or
That is the actual thing of the writing a transfer function because if you will take this P1, P2 and other things out, now your DC gain will change.
the case to change. Yeah.
Yeah, yeah, this is the
So,
correct way. 1 upon, yeah, okay, that's fine. Okay, so this is the correct expression for that. Okay. So what is the phase margin? Can you tell something about the phase margin from here?
we,
I want approximate the expression for the phase margin.
okay.
So
Oh,
now you have to write two things. One is that I want one thing. Okay, wait. One thing I want phase margin expression from you, and second thing I want UGB. And
okay.
if I want to improve the phase margin, what to do for the improvement? Third thing, what to do to improve the phase margin? To improve the phase margin.
Okay. First one is
So
phase margin.
yeah, phase margin expression I want from you, then UGB, and what need to do or improvement need to do to improve the gain phase margin.
Okay. I will say this as omega u, nothing but omega UGB. That is,
Okay. Okay.
this is angle coming from the second pole, and the
Okay.
phase shift coming from the zero is plus tan inverse omega u by zero.
Okay.
Okay.
Uh,
Okay. Second is UGB.
So can you more simplify this first expression term?
Okay.
In general, if I'm considering this is my first order system, if I'm
If
considering it is my first order system, then what should be the phase margin and what should be the constraints on second pole and zeros frequency? If I'm considering it as a first order system, then what's the minimum condition on your pole and zero, second pole and zero?
second pole should be almost 10 times of the UGB.
Okay, so basic thing it should be means after the UGB, if I'm
Yeah,
considered a
after
first
the
order
UGB.
system.
If it is
So
a first order system,
what this first term will reduce to?
reduced to 90 degrees
Yeah, near 90
because
degrees.
omega is
Yeah,
nearly 90 degrees.
Omega UGB is very greater than this pole one frequency, no?
Yeah.
So that thing I want to listen from you. So 90 minus some 10 inverse of these two terms, okay, and plus, okay. So
Uh,
what is the UGB?
UGB is DC gain into P1.
DC gain into
DC gain
P1 for the first order system in general, okay.
first. Okay.
Okay. I got the point. Okay, so I got what I want from this question. Now let I switch to the third question. Okay. Okay, so the question is op-amp is ideal. Two capacitors
Okay.
are there, two switches are there, 1 volt DC is applied in the input. Phi1 and Phi2 are two non-overlapping clocks. Two
Okay.
non-overlapping clocks. Okay. So I want output voltage, non-overlapping output voltage expression and steady state value of the output voltage. Okay. I want the
Okay.
steady state output and the expression or the plot of output voltage.
First, I want to draw the circuit for both clock. I mean, how circuits look like in each
Individually you
clock
want to draw.
individually.
Okay.
Yeah. When Phi1 is on, this is 1 volt. This is 1 farad. This is 1 farad. Okay.
Okay.
Can you scroll this side?
Okay.
No, enough. 1 farad during phi 2 phase. This is 1 farad, and this is 5 2. I think I am correct. This is fine. Okay, I think both circuits are fine
Okay.
in both phases. One farad. Let us see the response in this phase. At this node, it is DC source, so it is constant. Even though my virtual short trying to my feed op amp trying to make the V minus equal to V plus, but it is not going to happen because this is a 1 volt. So feedback is fails here. So there is no negative feedback. So I can say my Vout can go so during this phase here across this 1 volt comes across this capacitor, 1 volts will be there, and here I will get minus V set, and okay, during this phase whatever the 1 volts here, here negative feedback exists, so virtual short valid, this becomes 0 volt, so this capacitor discharges from 1 volt to 0 volts. Therefore in this case my output is 0. So if I try to plot the waveform, 0 1 uh, 0. During this phase my output is minus V set plus 1. I'm assuming this is phase 1, and during this phase my output voltage is 0
What is minus V set plus what?
plus 1 volt.
It is the output, huh?
Oh, sorry. Its output is minus V set.
Oh, okay.
Output is minus V set.
So what for this means coming phases?
And
With coming cycles of these phase.
this cycle repeats.
Okay. So yes, sure with this output, huh?
Um,
Okay, so let I should do some modification. So the same question, I want to do some modification. Same amp is ideal,
okay,
and I want the steady state output and also the plot for the output. 5 and
okay,
5 2 are non-overbreak blocks again.
okay. Similarly,
Hmm.
like previous, I will draw a circuit for both phases.
Okay.
Uh, this is 1 volt. Uh, this is 1 farad. Op amp is disconnected. Similarly, 5 pi 2, my circuit is,
You need more space.
oh, no, I don't know. Okay, this is 1 farad. This is 1 farad. The voltage across this capacitor is 1 volt.
Okay.
Um, Initially, if I assume this, what is the initial voltage across this capacitor?
It is zero only.
Uh, then in this phase, my output is 0
Okay.
because there is no current, though there is no path for to charge this capacitor.
Okay.
So I'm going from phase 1 to phase 2. I have 1 volt here, but a feedback exists, negative feedback exists, so which will not valid. So this becomes 0 volt. So whatever the 1 volt here is this becomes 0 volt. But whatever the charge present in this node, this capacitor, that will dump it into this capacitor. What I can say.
So how it will be dumped? I want exactly sign on the capacitor voltage. Feedback capacitor. How it will be dumped?
If I assume plus minus VC, I will apply charge conservation here at this node. Uh, this is 1 farad. This is 1 farad into 1 volt, but 1 farad into this I will call as VC. So this become this then this so V out, my V out will be the minus 1 volt. Yeah, in this case my V out is minus 1 volt. The whatever the charge coming is directly dumped in this fashion. This is plus terminal, this is minus terminal.
Okay. So what will be in coming cycles?
This is phi 1 phase. This
Hmm.
is phi 2 phase, which
Hmm.
is minus 1.
Hmm.
So so, so this for again phi 1 phase, this cap will not discharge. So this is like minus 1 only in this phi 1 phase also. Again this uh, whatever the 1 volt is trying to But give me a second. If I have 1 volt here initially, mm, that will become -2. So I think this cycle will repeat.
So it means -1, -2, -3, and so on.
Yeah.
Okay, I got the point. I got the point. Okay, now we want one more modification in the same question. I think, okay, I'll draw here. Now tell me quick, steady state output. Plot the output expression fast. Output voltage fast. Because now you already analyzed two circuits, so you can do it fast, hopefully.
Okay. For phi 1 phase, my output is 0, and for phi 2 phase, it is -1 volt. Again 0, again -1.
So it is behaving like a first circuit that we have
This
seen,
cycle
-1 0, -1 0, -1 0 kind of.
-1 0. Yeah.
Okay, okay, okay. So now what the point? Okay, so we will see the next question. These three questions are done. Fourth. Okay, okay. So I want input referred noise for the circuit. Input referred noise.
Okay. First, let us assume the noise sources. Here I have one noise source, and I need to consider the flicker noise or channel noises are enough.
Only one noise that we have considered usually. No flicker
Okay.
noise.
Okay. Hmm. This noise directly referred to input side. Uh,
How can you
Okay.
say?
Oh, yeah, okay. Okay, wait. Okay, sorry. Uh, Let me do one thing. I will find the output noise current. Then I can refer it. Even though, say, first assume this noise is not there. Only this noise current is there. Uh, Therefore, uh, s- this noise current directly, if I assume this as I out, so I can write this is second noise. So directly I out is I2. And now let us assume this noise source is not there, but this is present. This noise will not come into the picture
Why? Can you show it?
because this is constant current source. This noise will circulate here only. It doesn't have a path to come out because this side, if I assume this is an open circuit, small signal
Mm,
open circuit, this one. So
mm.
it doesn't have path to come, so it will circulate like this.
So
But
you mean to say, okay,
it has a path. Okay, wait. But it has a path. Yeah, there is another path here. So I think it will flow. Wait, sorry. It has a path. Uh, Here is zero. Here is zero. This is zero. Whatever. So no, there is no way for this. It will circulate like this only. It doesn't have any path. It will not come at the this output output current side because here is current is I only at this, or I can say this side is open. This side is open circuited. There is this this side is a current zero. This side is also current zero. So if I
okay,
apply KCL, so this will circulate here only.
okay,
It will
okay,
not come.
okay,
So my I noise. If I take the noise spectral density,
mm,
my I naught square is nothing but the I2 square. If now my target is to find the so I got the noise current. Now I need to find the gain so that I can easily refer to the or transconductance gain. If I can find the transconductance gain, I can easily refer to
refer to
input.
the input. Okay.
Yeah,
So what will be the equivalent transconductance for the circuit that you have to target now?
equivalent transconductance.
So what is the mean square current value in terms of transistor parameters that you've
Sir,
written in? What is this mean square current value of noise in terms of transistor parameters?
okay, 4 kT gamma GM,
Okay. Now you
4
continue
kT.
to calculate the GM. Now you continue to calculate the GM of the whole
Okay,
circuit.
here it is zero, zero. Can I use a small signal circuit?
Yes, yes,
or
you can use. You can use it. Better if you can just consider node voltages and write the current in terms of the voltages will be better. In case if you want to
okay,
use this small signal, then you can use.
this is 0.
Okay.
So I think I need to assume the R out resistances. Otherwise, I can't.
Hmm. Yes, yes,
Hmm.
because you want to calculate the.
I don't have path. So this is my R out resistance. So this is
This is around
GM
one. Okay.
R out 1.
Okay.
So this is GM V in 1. Uh, I will do one thing. This is GM V in. Okay. Therefore, voltage at this node is uh, GM V in
Hmm.
R01. Therefore, current through this node is uh, GM square V in R01. Okay. From
Oh,
here,
wait. Where is the node voltage you are assuming there's GMV in R not one?
this is 0.
How it?
The current flowing. This is the current flowing through this R01 is GM V in.
That GMV in, but is it the proper direction that you're considering? GMV in, it should go with the minus sign, no? Output.
It's sorry minus sign.
Okay,
This is minus sign.
okay, okay.
So
So overall, I can consider that you can solve now just to calculate the small signal trans. Oh, sorry,
uh,
means
so
transconductance for the circuit. Then just refer it to the input. So what is that input
yeah.
referred noise in terms of the transconductance of the circuit?
So this is the my gain is GM square R naught.
No, no, just I want like, okay, we got some capital GM let for the circuit. Then what is the input referred
Uh,
noise?
so this by capital GM. 4
This
KT
by
gamma GM
capital
by capital GM. That will give you the
capital GM or GM square?
if I assume this is capital GM. Oh sorry.
No, no, because you have a mean square
Sorry.
current, mean square
GM
current,
square.
no? Ah,
GM square. GM square.
okay, okay, Satya. Now also this session is going to be over. So, do you need more discussion or is it enough?
If fine sir.
It's fine now.
If you can,
Okay,
it's
okay.
fine.
Okay, now you have to revise whatever you have done and whatever you are lagging in. You have to just be focused and keep calm yourself while you are solving and focus on the fundamentals. Because in the first question, I have seen that you are missing something a
Yeah,
little.
yeah, sir.
It may happen in the
Actually,
actual interview also.
also, actually, there I